Alright guys, welcome back to the channel. So in today's video, we're going to be solving the first question from the chapter 6 of the Beer Johnston textbook, Engineering Mechanics, and we have to use the method of joints in order to determine the force in each member of the truss as shown, and we need to state that if each member is in tension or compression. So as always, we're going to start with finding out the unknowns that we have in this truss before we go to each joint and find the force in each member. And if we look at the member B, we'll see that we have a pin, meaning we have both X and Y component. We're going to show our X and Y in here. So this will be our BX, this will be our BY, and at point C we have a roller, meaning we can freely move in Y direction. So no force in Y direction, we only have force in X direction, we can call it Cx. And let's figure out the unknowns here. So we are in equilibrium, we can use the equilibrium equations, which are sum of all forces equals 0, and same for the moment. So we're going to start with sum of all forces in Y direction. If we look at it, we'll see that By is the only force that we have in Y, meaning By is 0, and if we go with our moment equation, either about point B or C, we can find one of the unknowns. So let's do the moment about point C. We have the moment of Bx, which is clockwise. So negative Bx times the vertical distance to the line of action. So 3.2. And we also have the moment of A, which is again a clockwise moment. If we look at it, so minus a times the vertical distance to the line of action. This is the line of action, and we are interested from C to here, which would be 4 plus 3.2, and this will be equal to 0. We already know A is 48 kilonewtons, so Bx basically would be negative 48 times 4 plus 3.2 is 7.2 divided by 3.2. And we have 48 times 7.2 divided by 3.2, negative 108 kilonewton. And the negative sign shows that the Bx is actually to the left. So our assumption was incorrect about Bx. So we have one more equation, which is sum of all forces in X direction. We have Bx, we have Cx, all positive since we assume that they are to the right, plus 48 of force 8 equals 0, and basically our C8 would be minus 48 plus 108, which is going to be 60 kilonewtons. No negative sign, that shows that Cx is to the right, and our assumption was actually correct. So now that we have this, we can move on to the free body diagram of each joint. We can start with joint B, and let's see what we have for joint B. If we look at the joint B, we have Bx, which we showed that it's actually to the left. So this will be a correct direction for Bx. We have two more forces that are these two. We can assume one direction for each of these, but if we look at this, we'll see that the only member that has X component is this member, which is the member FAB, and we have equilibrium equation. So we have to have an X component of one of these force to the right in order to cancel out Bx. That shows FAB has to be in this direction because this will be the X component and this will be the Y component. That way X component can cancel out the Bx. So that's the correct direction for FAB. And since we have a Y component upward, the other force that we have in Y direction, which is FBC, has to be downward. So this would be one easy way to figure out the direction for each of these members. So it won't be kind of shooting in the dark, but just assuming the direction. And it's actually pretty easy, but even if we assume the other way around for AB and BC, we're going to get a negative sign at the end that shows the direction. So for going for fx and fy, we need some angles. We can either find this angle here or the one with the x. Finding alpha is pretty easy in here because if we get back to our figure, alpha would be this angle, and we know this side is 3 and this side of this triangle is 4, so this is basically 5, and we can easily find the x and y components. So let's go with the sum of all forces in x direction. So basically we have FAB sine of alpha. Keep in mind that it's sine of alpha since we have the angle with y-axis. If we have the angle with x-axis, it will be cosine of alpha. And we have minus bx is equal to 0. And if I look at in here, sine of alpha would be basically 3 divided by 5. So FAB times 3 over 5 is equal to BX, which is what we found in the previous step, 108. And we're going to just put the positive value that we have for BX since we already counted for direction. So we have the absolute value in here. Keep in mind that we don't use 108 in here unless we assume BX to the right. So we can find FAB in here. So we have 108 times 5 divided by 3, which is 180 kilonewton. And we are sure about the direction of the AB, but that's the force that is applying from the joint to the member. So the member in here is actually in the opposite direction of the force, same amount. So the member in here will be in tension. So this will be in tension. That's one unknown. And if we do sum of all forces in y direction, we can find FBC. So basically FAB this time cosine of alpha minus FBC would be 0. So FBC is basically FAB, which is 180 times cosine of alpha. If we look at it here, cosine of alpha would be 4 divided by 5. So 180 times 4 divided by 5, 144 kilonewton. And again, the member BC somewhere in here, the force has to be in the opposite direction, so will be in tension too. So now we have the force in FAB and FBC. There is only one left, and that's the force in member AC. So we can do the free body diagram of joint C. So let's see what we have for joint C. So if we look at C, we have CX to the right, and we have two forces of FBC and FAC. So since the member BC is in tension, the force would be in the opposite direction. So this is the correct direction for FBC. And we also have FAC on the right side, which is this force in here. Again, this has to be in this direction in order to cancel out the CX, because FBC doesn't have any X component. So, well, FAC, and we can do the same thing. We can call this angle here, maybe this time beta, which would be this angle here. So if we look at this right triangle here, the base is 3, the other side is 7.2. So here our beta would be the tangent inverse of the opposite, which is 7.2 over 3. So this is going to give us tangent inverse of 7.2 divided by 3, which is going to be 67.38 degrees. Now we have beta. We can do our fx and fy. So if we do our sum of all forces in x direction, we have cx minus fac. Cosine of beta is equal to 0. We figure out cx from the first step. Cx is 60. So FAC would be 60 over cosine of 67.38. So we have 60 divided by cosine of 67.38, and that's going to be 156 kilonewton. And remember, AC would be in here. Again, the force would be in the opposite direction based on the Newton's law, so we'll be in compression, the member. So yeah, that would be the final answer for this question. Hope all this made sense. Let me know if you guys have any questions. We are solving different textbooks in this channel. Feel free to check out the playlists and let me know if you guys have any specific problem, then we can cover it in the next videos. You guys take care. I'll see you in the next video. Have a good one.